This is SpaceTime, Series 29, Episode 89, for broadcast on the 27th of July, 2026. Coming up on SpaceTime, a lucky 13th test flight for the world's biggest rocket. Scientists identified the type of asteroid that killed the dinosaurs, and a SpaceX rocket about to crash into the moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The world's largest and most powerful rocket has successfully launched on its latest test flight, bringing it a step closer to NASA's Artemis program, returning astronauts to the lunar surface and eventually onto Mars and beyond. The massive 124-metre tall Starship Super Heavy was on its 13th test flight from SpaceX's Starbase on the Texas Gulf Coast, some 63 days after its last test flight. A launch attempt a week earlier had been spectacularly aborted immediately after engine ignition due to technical engine problems. That resulted in mission managers eventually deciding to swap several Raptor engines on the Super Heavy's first stage. A second launch attempt several days later was also scrubbed, this time due to bad weather.
-9, 8, 7, 6, 5, 4, 3, 2, 1.
Vehicle is pitching downrange. Booster Raptor chamber pressure is nominal.
30 seconds into flight, 33 out of 33 Raptor engines lit on the Super Heavy booster arcing away from us here at Starbase.
The lucky 13th launch tested new hardware and software changes designed to improve Raptor engine relight reliability. It saw the first stage ignition sequence changed from that employed on test flight 12. These more powerful version 3 engines also meant Starship reached max Q, the point of maximum dynamic pressure on the vehicle, much sooner than on previous flights, at just T plus 58 seconds, and at a higher altitude.
Coming up on max Q, maximum aerodynamic pressure, which again for this flight is going to be higher than it has been on any of our previous Starship flights. Right, so we're passing through that maximum aerodynamic pressure over a minute now into flight. Still seeing 33 out of 33 Raptor engines lit and burning. Our next major moment's going to be coming up in just a little over a minute from now when we're going to get to hot staging. We're going to shut down all but 5 of those engines on the booster. It's our version of MECO. Most engines cut off. And then we're going to ignite the 6 engines on the ship while it is still attached, to do that separation. As a reminder, we try to do a directional flip. For the booster itself, it's like doing a flip up, and we do that by lighting the engines in a slightly staggered sequence. Standing by for hot staging. All but 5 engines down.
Except
6 ignite.
Burn startup.
And the booster now doing its boost back burn. It looks like we lit all 33 initially. Now we're down to 13. We're seeing 6 out of 6 Raptors lit on the ship.
Back burn shut down.
And boost back burn shut down. So it looks like we were able to get through the boost back burn this time around. That was one of the key objectives we didn't have on the last flight. Nominal. And we've got 6 engines lit on the ship. All right, so that's the first of 2 burns that the booster is going to be doing to kind of send it back towards us. It's going to be landing a couple of miles offshore from Starbase. Hopefully we're going to try and get it all the way down to do a landing burn, where we're going to use those 13 center engines. They're going to ignite. That's what's going to really bleed off all that velocity that it's built up, and it'll eventually hopefully transition to 5 engines to kind of fine-tune its path in, and then all the way down to 3 for the remaining bit. So booster's going to coast for a little bit.
This booster is not planning to come back to the tower or to launch site for this particular launch. We are going to be planning to do an ocean splashdown just off the coastal starbase. Now, just like on tower catches, we are going to be doing a 13-engine landing burn to slow the booster down. So right now, the booster is using their 3 hypersonic grid fins to guide itself through the atmosphere toward its landing site, 5 kilometers above the sea right here.
Emerge startup.
However, as the Super Heavy descended towards the blue waters of the Gulf of America, only 10 of the program 13 engines lit up for the landing burn. But then 2 engines suddenly shut down seconds later. That was followed by 3 more unplanned engine shutdowns shortly after that. That left just 5 engines burning, resulting in a faster rate of descent and a much harder splashdown than planned.
Just heard the call out for landing burn startup for the booster.
Just looking at the booster real quick, it didn't look like we lit all 13 engines that we were planning for that initial landing burn. We were targeting a softer splashdown, and it came in with quite a bit of velocity still, so landing velocity did look a little bit high.
Meanwhile, the Starship upper stage continued on its planned trajectory to a suborbital altitude, with the 3 sea level and 3 vacuum engines all operating nominally.
Ship still seeing 6 out of 6 Raptor engines lit. Ship's got about 4 minutes left.
Still following the planned flight path as well.
Starship on nominal trajectory.
Everything continues to go well with ship.
Yeah, we've got about a minute left with the ship engines on. All eyes on ship. We are just a little ways away from getting those engines turned off. We expect it to burn about 8 minutes and change.
Then 8 minutes into the flight, Starship's 6 Raptor engines were shut down as planned, with mission managers calling a nominal orbit insertion.
And engine shutdown. All right, Starship's 6 Raptor engines have successfully shut down.
Nominal orbit insertion.
And there's our call out for nominal orbit insertion. So we got a ship in space. We've got a booster in the Gulf where we were planning to send it.
This is the second flight of Starship version 3. This is flight 13.
A quarter of an hour later, Starship's payload bay was opened and the Pez dispenser began releasing its 20 Starlink version 3 satellites.
We've got 20 of these Starlink V3 satellites. This is the first time we've got Starlink V3 satellites getting ready to go into space.
These next-generation Starlink version 3 internet satellites are larger, flatter, and equipped with laser communications links and expansive solar arrays that will eventually replace SpaceX's current Starlink internet mega constellation.
And I mean, these things are really just kind of crazy upgrades that they're going to bring to the network, where you start talking about just symmetric gigabit speeds through the Starlink network pretty much anywhere on the planet that this is going to unlock. So really exciting. These will only be in space for about 20 minutes as they're on the same suborbital trajectory as Starship itself. This is essentially just giving us a chance to try and run as many tests as possible, deploy the solar arrays, antennas, whatever we can on these vehicles. We are intentionally being a little scrappy with it. They might be playing some bumper cars once they're out of the door, but we are looking to get these deployed over the next couple of minutes.
First Starlink V3 getting deployed out of Starship. Huge milestone for the team out here.
We could see these Starlink V3s continuing to pop out with deployment assisted by the Pez dispenser. Now, this version of Starship is built to deploy up to 60 of these more advanced Starlink version 3 satellites. Each V3 is designed to offer 1 terabit per second of downlink capacity. Now, let's put that into Falcon 9 terms real quick. A Starship launch with V3 satellites will launch 20 times the capacity into the constellation as a single launch of V2 satellites on Falcon 9.
We've got about 3.5 minutes still left of our payload deploy sequence.
Yep, looks like we've got 16 satellites deployed, so 4 more to go. 17 out the door, 3 more to go, and 18.
Just at 25 minutes into our flight, it's crazy to think that we're already screaming at 27,000 kilometers an hour, 200 kilometers above the ocean surface.
These are fully, these are real satellites.
Right.
They're not just demonstration sats like we had last time. These are going to basically have a 20-minute lifespan where our Starlink engineering team will attempt to perform a number of tests and really speed run those tests during that time.
Right. And in terms of satellite lifespans, 20 minutes is it's the shortest you could possibly get, but hopefully in that 20-minute time frame we can really try and ink out as many tests as we can.
19 out the door, one more.
And that marks, if I'm not mistaken, our 20th. So our payload deploy sequence is now complete. Starship will now close its payload bay door and continue to coast around Earth to the Indian Ocean.
We can also confirm that we managed to make contact with all 20 of those V3 sats, so it's a massive day for us.
39 minutes into the flight, mission managers reignited one of the Raptor engines for a 13-second burn, the longest Raptor orbital relight undertaken so far. This is a critical test designed to allow future starships to enter and leave orbit.
We are going to be lighting one of our sea-level Raptor engines. This is essentially just a demonstration that you can relight an engine after it's already done its ascent burn, and this is going to be really important when we do maneuvers for orbital missions, whether we're relighting to go into orbit or if you're already in orbit and you're getting ready to do a deorbit burn. We did hear our Raptor team is go for the engine relight, so not going to be skipping it on this one. Again, this is not a deorbit burn for this ship. We are on a suborbital trajectory, so this starship is coming back over the Indian Ocean no matter what. But this is going to be a pretty critical test for what we'll eventually need to do when we do orbital missions. When you got to relight those engines, do a burn to get yourself out of orbit. One thing that is unique on this one is we're going to be lighting it for a little bit longer of a time. We've only done about 3 seconds previously.
Relight demo startup.
And confirmation over the net, relight shutdown. The burn has ended.
T plus 47 minutes and 30 seconds into the flight, Starship began its atmospheric re-entry above the Indian Ocean.
Starship is starting entry. Good attitude for entry.
The ship is currently re-entering the Earth's atmosphere.
So re-entry, it's a critical phase of flight, and we need information on how the ship's systems perform.
We'll collect valuable data on the spacecraft flying through the Earth's atmosphere, and it's doing so at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or about 5 miles per second. So at those speeds, the spacecraft is moving through the atmosphere so fast that it creates a plasma field around the vehicle.
That blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. Starship is designed to land on Mars where there are no runways or other humans to help out, which is exactly why we're testing this landing procedure that we're doing today. And we're doing these propulsive landings instead of more traditional means like parachutes because propulsive landing...
control of the vehicle.
You heard that call out, flaps do have control of the vehicle.
Now, when we hear something called entry max heating as well as entry max Q, that means that the ship has made it through the maximum heating and aerodynamic loads that it experiences as it returns. So safe to say that if it makes it through those specific points, we're doing pretty well.
That's right. So we'll continue to hear multiple call-outs as we go through this phase. One of those call-outs will be that the ship is transonic. We'll also hear another one when it's subsonic. Transonic will be referring to the period of flight where velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most fly at roughly Mach 0.74, 0.85. Just for reference, that's between 480 miles per hour to 575 miles per hour, or 770 to 930 kilometers an hour. Subsonic will refer to speeds that are much less than the speed of sound. So at this point in flight, the ship's velocity will be slowing down drastically.
It quickly became wrapped in a cloak of glowing superheated plasma as it plummeted back towards the Earth. As with the previous flights, SpaceX used this mission to test various options, including different heat shield tile attachment methods. Other experiments tested different materials and used special load-sensing tiles on the heat shield. It's generally thought the tiles all seem to hold up well, with only a handful missing or damaged and no signs of any burning through on the flaps or leading edges.
Starship's heat shield, which from kind of our initial looks, it did pretty well on the flight uphill, but we'll continue to dig through all the visual data.
Starship is leaving the peak heating phase of entry. External temperatures are coming down.
Control flaps guided the spacecraft's orientation as it plunged through the atmosphere, helping to bleed off orbital velocity. These independent front and rear flaps actively move to maintain aerodynamic stability and roll and pitch control during the superheated plasma phase of re-entry.
Starship is at maximum entry dynamic pressure.
We made it through max heating and max dynamic pressure, meaning that the vehicle temperature and speeds and pressure are all coming down.
As it descended, Starship began executing a specialized banking turn known as the swoosh maneuver. On future missions, that'll help position the spacecraft for its final approach to its landing site.
Starship is executing the swoosh maneuver. Dynamic pressure is coming down.
We're doing the swoosh maneuver. This is kind of the final maneuver that we plan to have starships returning to Starbase do. That will essentially hook them out over the Gulf before coming in and over Tower 2.
Starship then reconfigured itself into a horizontal belly flop position in order to bleed off more speed in preparation for the landing burn. Cold gas thrusters then fired to pitch the spacecraft from its horizontal belly flop position into its vertical attitude landing position.
We're coming up to the ship landing burn.
We're going to try and light all 3 Raptor sea level engines for this burn.
As it reached the lower atmosphere, Starship reignited its 3 sea level Raptor engines for the landing burn, eventually shutting down one, then a second, as it slowed its rate of descent and softly splashed down into the Indian Ocean off the Western Australian coast.
3 sea levels lit. Seeing healthy chamber pressures on. Did our flip down to 2. Starship descending into the Indian Ocean, down to 1, and we're in the water. And it's a soft splashdown in the water.
As it splashed down, it cut off its remaining engine and then gently tipped over, floating fully intact on the surface, bobbing up and down in the crystal blue waters. And that was different to previous splashdowns where the vehicle exploded and sank on landing.
That is a first. That is the softest splashdown we have ever had with the Starship there in the Indian Ocean.
It's bound to be an exciting day for our recovery team. I mean, that huge milestone to even get to soft splashdown, much less have the vehicle stay afloat.
Floating so serenely in the Indian Ocean.
SpaceX boss Elon Musk says the successful flight met all of its mission milestones. He says this now moves the program a step closer to full orbit entry and future catch attempts back at the launch site rather than the Indian Ocean. This is SpaceTime. Still to come, scientists identified the type of asteroid that killed the dinosaurs, and a SpaceX rocket about to crash into the moon. All that and more still to come on SpaceTime. A new study has determined that the asteroid which slammed into the Earth 66 million years ago, wiping out some 75% of all life on the planet, including all the non-avian dinosaurs, was most likely a rare CO-type carbonaceous chondrite. The findings, reported in the journal Science Advances, are based on a new advanced nickel isotope analysis of samples, narrowing down the composition of the deadly 10 to 15 kilometre wide KT boundary event asteroid which struck the Chicxulub region of Mexico's Yucatan Peninsula. This mountain-sized space rock hit at an estimated 64,000 kilometres an hour, creating a 180-kilometre-wide crater and triggering planet-wide violent volcanic eruptions, global earthquakes, and massive tsunamis in all directions, in the process sending a huge cloud of dust and burning debris high into the atmosphere, blocking out the sunlight for months, if not years, and sending the entire planet into an impact winter. Carbonaceous chondrites make up just 5% of all the meteorites so far sampled on Earth. And carbonaceous chondrites of the Ornans class, the CO chondrites, make up only a tiny fraction of that group. They're some of the most primitive and untouched materials in the solar system. One of the study's authors, Philip Clays from the University of British Columbia, says carbonaceous chondrites of the Ornans class are not like the typical meteorites that you find in museum collections. These CO-class rocks contain far less volatile elements, like carbon, zinc, water and sulfur, compared to other classes of meteorites discovered on Earth so far. Cleese says while it doesn't alter our current theory of what caused the extinction event, it makes it less likely that sulfur contained in the impactor was the smoking gun. Based on this new data, the fine debris thrown up into the atmosphere would have been the primary factor. The authors reached their conclusions by conducting high-precision nickel isotope measurements of samples collected over many years from a thin layer of iridium-rich clay blanketed right across the planet and created by the impact event. This iridium-rich layer is known as the Cretaceous-Tertiary or KT boundary. All over the planet below this boundary, you'll find non-avian dinosaurs, and above it, they've all ceased to exist. Cleese says the research was challenging. That's because only a minute fraction of the projectiles preserved in the boundary layer, most of the parent asteroid having vaporized on impact. Still, many questions remain about the origins of this world-changing asteroid. Potential sources include giant, debris-rich regions of the outer solar system, or even the outer area of the main asteroid belt near Jupiter. Cleese says being impacted by such a rare giant projectile underscores just how unlucky the non-avian dinosaurs were. This is SpaceTime. Still to come, a SpaceX rocket about to crash into the moon, and later in the science report, a new warning that a third of all heart-related deaths could be due to ultra-processed foods. All that and more still to come on SpaceTime. The upper stage of a SpaceX Falcon 9 rocket's about to slam into the moon. The impact on August the 5th will be visible from Earth and provide scientists with a new method of pinpointing exactly where objects strike the moon, data that could help prepare for future lunar seismic experiments. The abandoned upper stage will crash down onto the lunar near side's Einstein crater at an estimated velocity of around 8,750 kilometers an hour. The booster, catalogued as 2025-010D, began its journey in January 2025, carrying 2 private robotic landers towards the moon. After successfully deploying its payloads, the 12-metre-long 4-ton rocket had depleted its fuel supply, therefore couldn't propel itself safely into deep space or back to Earth to burn up in the atmosphere, and so it was left drifting in the darkness of space. Now a report in the pre-press physics website archive.org has tracked the booster's flight path. The study's author, astronomer Bill Gray, says computer simulations suggest that because the rocket's really nothing more than a hollow metal shell, it's unlikely to penetrate deeply into the lunar surface, as say a solid asteroid would. Instead, it'll be crushed on impact, creating a new, roughly 20 to 30 metre wide crater on the lunar landscape and sending a large cloud of debris and lunar dust several kilometres into the blackened sky. And this dust cloud is exactly what Gray and colleagues will be looking for. He's called on professional astronomers and citizen scientists around the world to also get involved. Potential observables from the event will include the flash of impact and the ejector plume as it rises from the surface. Now, for those interested in joining in, the impact will happen at 6:35 in the morning Greenwich Mean Time, that's 16:35 in the afternoon Australian Eastern Standard Time, and 2:35 in the morning US Eastern Summer Time. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that around a third of all heart-related deaths may be due to the consumption of ultra-processed foods. Ultra-processed foods include things like soft drinks, chips, candies, mass-processed packaged bread and sweet breakfast cereals, as well as ready-made frozen meals, hot dogs, chicken nuggets and deli meats. A report to the International Congress on Obesity suggests that between 23 and 38% of all cardiovascular deaths and between 23 and 37% of all cases of cardiovascular disease, including coronary heart disease and stroke, are attributable to consuming ultra-processed foods. The study looked at the diets of Canadian adults in 2015, finding ultra-processed foods made up 43% of their daily energy intake. The authors then calculated that between 58,200 and 96,000 new cardiovascular disease cases and between 10,600 and 17,400 cardiovascular disease-related deaths were attributable to ultra-processed food consumption by 2019. Their modelling suggests that cutting ultra-processed food consumption by 50% could have prevented around half of all new cardiovascular disease cases, as well as cardiovascular disease-related deaths. A new study suggests that fewer people in Australia are now smoking. The data from the Australian Institute of Health and Welfare shows rates have steadily fallen over the past 2 decades. In 2025, 5.6% of the population aged 14 and over were daily smokers. That's down from 8.3% in 2022 and 23 and 19.5% in 2001. And this equates to around 1.3 million people smoking daily compared to 3 million smokers in 2021. On the other hand, daily e-cigarette use has gone up slightly. Vaping now stands at 3.6% compared to 3.5% in 2022-23. Scientists have identified high levels of vehicle tyre dust on local Brisbane apartment building balconies. The findings, reported in the journal ACS ES&T Air, are based on the identification of tyre particles and potentially toxic tyre chemical additives found in dust collected from residential balconies. The research by the University of Queensland examined balcony dust from homes across the inner city, as well as suburban areas and especially near road settings, in order to see how traffic-related pollution travelled from streets to residential environments. Israeli intelligence has confirmed that Iran has transferred thousands of advanced uranium enrichment centrifuges, as well as some of its already enriched uranium stockpile, to a new subterranean complex buried in granite deep under Pickaxe Mountain, 2 kilometres south of Natanz. The move suggests that the Islamic Republic is using the fortified underground site to continue its nuclear weapons program by further enriching uranium to full weapons grade. Tehran currently has enough weapons-grade uranium to make between 9 and 12 nuclear weapons, based on estimates from the International Atomic Energy Agency. Iran currently holds a stockpile of roughly 440 kilograms of enriched uranium up to 60% purity. The weapons-grade enrichment threshold is 90%. Satellite observations indicate the Pickaxe Mountain facility could support advanced centrifuge assembly, meaning further enrichment, as well as other nuclear weapons programs. The complex under Pickaxe is accessed by a network of concealed tunnels. Analysis suggests the new complex is at least 100 metres below ground, making it deeper and far more fortified than Fordow or anywhere else the United States has struck so far. Construction at Pickaxe first began after the 2020 sabotage of the Natanz complex as a hardened fallback site. Neutralising Pickaxe Mountain would require multiple B-2 bombers dropping GBU-57 massive ordnance penetrators in coordinated waves, along with electronic warfare, suppression of enemy air defences, real-time intelligence, surveillance and reconnaissance, and repeated strikes on tunnel entrances, ventilation shafts and other supporting infrastructure. However, analysis suggests that this mountain complex may simply be too deep for conventional bunker-busting bombs to fully destroy, making access denial and operational paralysis a more realistic objective, that is, other than a targeted nuclear strike by either the United States or Israel. We already get plenty of fake news stories from so-called legitimate sources like CNN, the New York Times, the BBC, and of course Australia's own ABC, all of which openly push their own lies and political narratives in the guise of real journalism. And now it seems like shonky commercial companies are following their lead, with dozens of fake news pages on Facebook cropping up, claiming to be reputable news distributors. The Skeptic's Tim Mendham says they're posting fake scandals, alleged cover-ups, dodgy rorts and rumoured fractures within government, all in a bid to mislead thousands of readers in order to get more clicks.
A report that came out recently looking at a few phony news pages, looking like websites of news outlets in Australia, and I'm sure they're everywhere as well, having fake news stories. Some of them with videos, and I've seen some of these. There's some in Australia, there's some in the UK. There was a classic one of Nigel Farage, the head of the Reform Party, attacking an interviewer on screen with a very sort of angry-looking face, totally made up, deep fake. And there's news reports, so-and-so is dead, this person has attacked this person, whatever, major scandal, whatever. What they're doing is they're clickbait, trying to get you to click on, and they often take you to another website which says, by the way, would you like to buy this product, whatever, or just getting traffic as much as anything else through sensationalism. And this is false sensationalism as opposed to pure exaggeration. Interestingly, some of the pages that you go to are actually themselves fakes, which then take you to somewhere else. It's a sad indictment of what happens with social media, that any of these things can get attraction. People's critical thinking capacities are not pressured. I mean, I see them every day. I get spam messages every day by phone or by email, and sometimes you see them on the news or on online videos. It's what they call engagement-driven advertising model. So basically, they want what we refer to kindly as bums on seats, numbers of people, and that's the way they maximise their profit or their income. And an article recently about these particular news sites says the appearance of a marketing platform or domain linked to these pages does not necessarily mean that company is behind the activity. In other words, someone is hijacking someone else's site to then create a fake site. It means that the public has to be constantly aware of fake information that they're getting. And because the AI systems, the video systems are getting more and more sophisticated, it's getting harder to assess these, which means you're eventually going to reach the stage where you don't trust anything. Either you read or see or hear. And that's probably not a great place to be.
I remember when I was a kid, there was this thing called the Sydney Morning Herald, which was
Herald.
It was brilliant. And their lead story was Queen abdicates. And I was reading it on the train. People were milling around me because they thought it was real. It was very amusing. That's the Skeptic's Tim Mindham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.